Today we are going to discuss about the rest of the topic that has been left for requirement engineering or requirement analysis part that we were discussing in the class last on the last turn. So we are going to see some more diagrams. We had discussed use case diagrams. We had discussed swim lane diagrams. We had discussed activity diagrams. So now come to the next field of diagram that are known as data flow diagrams. So a data flow diagram is a diagrammatic form that is used to represent how data objects are transformed as they move through the system. So I have explained this to some of the students. So now when your data flows from an input entity to an output entity, then you will see how your data is being transformed from the raw data, that is the data which is coming from the user as it is, and how you are going to perceive it, how you are going to see at the output level. You have done this in your C program, like when you pass two variables from a user input from a console and you try to process it, and finally you will see a structure, or you see a file system, or you see a particular data in the process form. So you see that the data flows from the input devices and is displayed on the output devices. Both are different and both are now like taken and processed. So this can be depicted using data flow diagram. So a data flow diagram, this transformation is represented using various level of abstractions. Like means you cannot show everything to the customer at one go. You have to slowly and slightly tell him that this is the initial part with the highest level of abstraction. Then you go and then you decrease the level of abstraction. You let him know these are more modules. This is the more modules, and that's why you will make him understand, or not a customer but a designer, that this is what he has to build. So the level of abstractions are divided into the level 0, level 1 and so on. So level 0 is the easiest DFD that can be drawn. It has a single process and it has set of inputs and set of outputs. Okay. So we will see how it looks like in the next slide. But level 1 will try to elaborate this process which was there in the level 0, and level 2 will again try to process more what are the more entities that are there inside the process. So let us see a safe form DFD which has been given in your book. The safe form DFD, if you see, it has this control panel as an input and a sensor as an input. These are the two inputs that has been there, and it is giving their input as a user command and data or sensor status to the safe form process. Now the safe form process, inside this SafeHome, we are not bothered that at this level, a context level or zero level, we are not bothered that this what is there inside the SafeHome. We only can see that whenever the control panel sends a user command or data, or a sensor sends certain status, the user SafeHome software will do certain processing and it will display the information at the control panel display, or it will raise an alarm using alarm type. Maybe different alarms might be there, or it can you can call to the person in case of emergencies. So this is what is called context level, that we hide everything what is there inside this particular process, how things actually happen. We just generally like abstract everything from the user. We generally tell him that this is a set of inputs that is being given by the customer, and this is a set of outputs that will be received after the system has been already processed the data. So in a context level diagram, you only have set of inputs like here and set of outputs like this one, and a single process. Now in the level 1, what we are going to do, we are not going to add more inputs or more outputs. We are going to elaborate this process only. So in level 1, we elaborated this safe home process. Okay, safe home process has been like elaborated with many more processes, because this safe home process cannot work on its own in isolation. So the safe home generally works with in accordance or in collaboration with many other processes. So now this, you can see the safe home process. If you see this diagram, you can easily see that this control panel gives the user command comes in, and it gives the first process that interact was interact with the user. Then it has three more branches. There are three more processes coming up, and you can see a sensor is only working with the monitor sensor process, and the display message status is giving to control panel state display. So you can see now you can easily see the different type of processes that are part of the safe home process. Now, if we want to increase the level of abstraction, and let us see one of the scenarios like sensors, how this sensor monitor actually works. So we will elaborate now each every process. In level 2, we will take one configuration system, interact with user, activity deactivate system, how actually these systems are going to work. So this is monitor sensor process. This is the monitor sensor process you can see here at the bottom, and we are going to elaborate this particular process in the level 2, and we can see that this particular sensor, it has an input from sensor data. Okay, and the sensor data has many other processes coming up. So likewise, what you do is you keep on incrementing, you keep on adding more processes, but the addition of the process will be in certain levels. It's not, you cannot draw one diagram with lots of processes coming up. Initially we have to draw something like this, then we'll elaborate it, the process like this, and then we each process might be elaborated one by one. Okay, so the processes are shown in the what you can say, the processes can be shown in a particular format like a circle. Inside a circle, we name the process. We can show arrows that takes the input, and the arrows we can going out from the process is the output. And we also see certain information like configuration information in a box or a parallel lines. They are the databases, or you can show a data repository which are giving certain data back to the process. Okay. So all this was a brief introduction about DFD. Now you can try to see how you can draw a DFD for your anything that you see in around like a computer system or a mobile system or any other system. You can see that easily. The next diagram is called state transition diagram. The state transition diagram indicates how the system behaves as a consequence of external events. That means whenever we have an event coming up, we have a particular uh, what you can say, a system, right? Like a fan or tube light. What it will do whenever a tube light is easily you can see in a room or in wherever you are sitting right now, you have a bulb or a tube light around you. If it is in on state, you press the button in off, it will turn the light off, right? So the state that is currently in is state 1, and when you give an external input or external event to this particular system, the system goes into a different state. It's either, or if it is on, it will go into off state, or it's off, it's coming back into on state. So this is how this type of things is usually depicted in by state transition diagram. The state has to be transition from one state to another state. The state transition diagram represents the various modes of behavior called states of the system, and the manner in which the transition are made from the state to state. The state transition serves the basis of behavioral modeling. So we will generally use behavioral modeling, that how system actually behaves when we different type of inputs are given to a particular system. So we can see this with the help of a small diagram here. This is a state transition diagram for a photocopier machine. So you can see the rectangles represents the state, right? The arrow represents the transitions between the states, and the arrow is labeled with the ruled expression. So I have a ruled expression. The top value indicates the events that actually triggers that state, and the bottom value indicates the actions that occurs as a consequence of the event. A guard is a boolean condition that must be satisfied in order for the transition to occur. So if we start this particular studying this particular um, state transition diagram, we can see that we have multiple state like reading commands, reloading paper, making copies, and diagnosing problem. So if I say reading commands, Reading command means if it is the system is in idle state, invoke read output input, right? So event is it's waiting for a action, that is invoke read uh, or read operation input. So once you full and start, this is the event. When you full and start, invoke managing copying. So you the system from this state of reading commands, when it is full and started, the system will move itself to making copies. Right? This is whenever you click a start button and the system tray is full, it will invoke this action, that it will invoke manage copying type of function. It will go to the making copies type of uh, event state. In this state, if the tray is empty, invoke reload paper. So it making start making copies. Suppose the tray has empty. After doing certain copies, the tray become empty. At that time, it will again shift itself to a new state called reloading the paper. That when this loading paper is full, again in take the input. So again it will go back making copies. Now, if you're making a copy, then you get jammed. The system might get jammed, right? When you get jammed, then it will go invoke another module which is called diagnosing. This state is different, diagnosing problem. Once it is cleared the jam, it will again go back reading commands. Okay, when your complete action has been done, the invoke output is called. It goes here, and when this complete copy is done, it will come back to reading command, and it again become idle. So this type of diagram, which tells you the multiple states of a particular object, it goes right. Multiple things it can take care. Now, at multiple events and multiple actions are there. So might be possible there you can make some maximum copies. So if we can say, if you have this, whenever you are starting this, there is a company the number of copies should be more than 100 maybe. So that condition, if the copies are more than 100, you should stop copying. So that is called a guard or a boolean condition coming up. Likewise, if you take this diagram of a state diagram for from the sensor display, say that you have a control panel. The control panel right now is at rest because doesn't have any command. Whenever you try to enter a password, the control panel remains the same, but the state changes. The state changes it to a state called comparing, right? Now the control panel is comparing it, and if it is wrong password, the state changes to re-enter, or if it is correct password, it will go to selecting the options you have, right? Once select the option, the control panel again activate successful. It will come back to the rest, right? If it is not, then it will come back to again at rest. So this is the state transition diagram for uh, sensor system control panel that you have seen. This is a third example of a state transition diagram. It says that I open an account. When I start to open an account, I have an empty account. Okay. Then I set up an account. So I will, whenever I try to set up an account, I start entering my data, some the details that I have. Then the system changes from an empty system to a setup account system. The separate account system now is initiated. I deposit certain initials. I will go back to working account because now the account has been initialized with certain data, certain money, certain amount. So data now is in this working account status. At working account status, I can deposit, I can withdraw, I can balance credit in account information. I can do multiple things, but I will always remain in that particular working account status only, right? Now I did withdrawal final. That means I now after certain years I want to close that account. So what I will do, I will withdraw this final amount and I will now non-working account. So from working account I shifted to a non-working account and finally I close that account. Account become dead account. So these are the states represented by rectangular blocks. These circles, this loops coming up because I am in the same state. So I will keep on using these loops to this big that whenever you trigger this events like deposit or withdrawal or balance sheet, you remain the same state only. And this type of state transition diagrams you will actually have to draw once you study automata, final state automata, and then you have to draw the states, and you are more bothered or concerned about the states. But system generally works on different states. So state transition diagram is about it's all about the states that an object is, and once you give an external input, how the state changes and which state it comes in, what are actions you need to do, what are events that are related to that particular state. The last diagram that we are going to discuss is called sequence diagram. It indicates how event causes transition from one object to another object. Now, object level. Uh, Second diagram which tells you how objects actually works, right? Once an event has been identified by examining a use case, the analyst or modeler creates a sequence diagram. It represents the key classes, the events that causes the behavior to flow from class to class. So let us see this. What are the main ingredients of sequence diagram? You have a lifeline which is shown by a rectangular bar here, right? Both the sides. So lifeline 1 and lifeline 2. The lifeline 2 starts with the message start event and a message end event, right? Focus. Or message end event is also there. So message start from here, message 1, and ends up here, message 2, right? Now, once you end up here, the execution occurrence start event. That means in lifeline 2, once your system reaches the other end, the system is start executing it, and it returns back the message back to the line lifeline 1. So the message lifeline lies from the start to the focus execution occurrence, right? So you have to maintain a particular status like this. So if we take a diagram, before that let us understand this is bold line and light line and this dash line. Synchronous message between active objects indicate waits semantics. The sender waits for the message to be handed before it continues. It typically shows a method call. So in synchronous message like handshake, networking handshake, whatever happens when you want to start a networking handshake, the two devices sends a packet to the device, and the server or the client will wait for the acknowledgement to come back. If the acknowledgement comes back, then it sends another package. This is called synchronous transmission. And another way is when send your bulk mails. When you send a bulk mail, you are not bothered whether the mail has been read by the person or not, but you are more concerned that the data has been sent. So that is called asynchronous mode. And this dash line sends this shows you the reply message that is returned back by the for the message. So now if we try to draw a a sequence diagram for a bed allocation system, then there is an object called day nurse and the class called nurse. So day nurse colon nurse, that means day nurse is an occurrence, an object of the class called nurse. The first event is admit patient, right? So admit patient will, whenever this message is being rolled, this a nurse is another object of that particular nurse. Now it tries to allocate a bed. It will call this allocate bed. Allocate bed should be done in less than 2 seconds, right? So it will go to the object called bed2 in a class called bed. It will try to find is free is a like in the class called is free. It doesn't have any object, right? So it will go one. It will again call bed. It will again see is free. So is free is a loop. It's trying to find for every 2 seconds. It's going to find this bed. So 1.1 says bed is equal to allocated bed. Once it finds a bed, it will then sends you a data 2.1. It will come back with the data, right? So at the C level, the C minus A is less than 5 seconds. So it's calculating the time also at the same time. So the sequence is first the nurse will admit the patient, then it will ask the system, it will check the system for the bed allocation. If the bed allocation is fine, it will send you the content of the bed to the nurse, and finally the nurse will create the record and patient record is added into the record object. So this is a sequence diagram for your system. So you might be required to study six diagrams: the use case diagrams, the activity diagrams, the swim lane diagrams, the data flow diagrams, the sequence diagrams, and the state transition diagrams. So these are the six diagrams that will be a part of your course, is your midterm. And class diagrams also there, but we study class diagrams when we will do the unit. So thank you very much. We will be continuing with the lectures online sometimes, and it will be very helpful for you to study these diagrams offline as well. Thank you very much.